Imagine a weapon so unusual, so far ahead of its time, that it could reveal human silhouettes through walls, long before thermal cameras were ever invented. A soldier adjusts a strange metal apparatus, part spotlight, part scientific instrument. A beam of white light cuts through the snow, and on the ruined brick wall ahead, shapes begin to appear. Human shapes, glowing, moving. This is not science fiction. During World War II, Allied engineers quietly tested a real device capable of detecting warm bodies hidden behind rubble, smoke, and darkness. A device that used nothing but vacuum tubes, thermal optics, and a blazing hot filament chamber to paint living targets onto frozen city ruins. A device so secret, so experimental, that for decades its very existence sat buried in storage crates and forgotten memos. They called it, unofficially, the heat gun. But its true purpose was far stranger than a weapon. It wasn't built to kill, it was built to see. The year is 1943. Europe is burning. And in the ruins of bombed-out cities, where smoke and winter storms turn everything to darkness, one problem keeps returning to Allied commanders. You cannot fight an enemy you cannot see. Searchlights reveal your position. Flares last seconds. Primitive night scopes blur with fog, and every ruined building becomes a perfect hiding place for ambushes. So Allied engineers begin experimenting with a radical idea. What if you could detect the heat of a human body without needing light at all? In a small laboratory lit by dim lamps, an engineering team assembles one of the strangest battlefield devices of the entire war. A monstrous, lantern-shaped machine built from vacuum tubes, focusing mirrors, and a glass chamber heated until it glows white. They claim it can reveal the warmth of a human body through smoke, fog, and even thin walls. At first, no one believes them. But when the first prototype is carried into the frozen streets for testing, everything changes. The operator activates the lamp. The chamber ignites with a hiss. A beam of brilliant, shimmering light blasts forward. And then it happens. A faint outline, a figure, a human silhouette, glowing against the brick surface. Not reflected, not painted, detected. The engineers stare at each other in disbelief. The impossible is now real. This single moment launches one of the least known military experiments of World War II. A project so strange that modern historians almost dismissed it as myth. But it wasn't a myth. It was a precursor to thermal vision, built decades too early. And if it had worked perfectly, it might have changed night combat forever. To understand why the heat gun mattered, you have to imagine a winter battlefield in 1943. Temperatures far below freezing. Snow swirling through streets already choked with dust. Visibility nearly zero. Night raids, urban assaults, these were nightmares. You couldn't see 5 meters ahead. You couldn't locate hidden snipers. You couldn't tell if a ruined building was empty or filled with enemy soldiers waiting in the dark. Commanders begged for a solution. Spotlights revealed your position. Flares illuminated you before the enemy. Early night optics fogged instantly. And radar couldn't detect human bodies through walls. So a new theory emerged. If human bodies radiate heat and cold ruins absorb it, maybe the contrast can be made visible. This idea gave birth to the first prototype, a machine that didn't detect light, but detected temperature difference, using glowing internal chambers and optical manipulation to reveal warm silhouettes. This was decades before digital sensors. No electronics, no microchips, just raw heat, glass, and physics. And for a moment, just a moment, it seemed like this thing might actually work. To understand how this bizarre WWII heat gun worked, we must break it down piece by piece. And the first thing you notice is that it looks nothing like modern thermal cameras. There are no sensors, no digital screens, no electronics in the modern sense. Instead, the heart of the machine is a cluster of vacuum tubes arranged around a glowing central chamber. These tubes aren't amplifying radio signals, they're amplifying heat contrast. Their job is to take tiny differences in temperature and make them visible to the human eye. The entire machine is built around three key components: a high-intensity filament lamp, heated until it glows white-hot inside a sealed glass vessel; a parabolic focusing assembly, reflecting and filtering the radiant energy; a thermal differential chamber, where warm bodies, even behind thin walls, disturb the pattern of emitted light. Everything is mounted onto a military tripod because the device is far too heavy to hold. The operator stands beside it, adjusting knobs that control the temperature, beam spread, and optical clarity. It's less like a weapon and more like a scientific experiment placed directly on the battlefield. So here's the real question. How do you see heat without using infrared sensors? The answer lies in a strange optical effect. Hot objects subtly distort passing light. Cold objects absorb it. The engineers realized that if you created a controlled beam of heated light and projected it onto a surface, you could then observe how that surface re-emitted thermal energy. This is where the heat gun becomes truly strange. The glowing chamber acted like a primitive thermal scanner. The chamber produced a very specific wavelength range, somewhere between visible light and near infrared. This energy reacted differently when it struck. Cold brick, warm skin, metal objects, cloth of snow or ice, warm human bodies, even when hidden behind thin materials, produced a subtle but detectable thermal bleed-through, appearing as soft, glowing silhouettes when seen through the device's optical view. The effect was not sharp or detailed. You couldn't see faces, weapons, or movement with precision, but you could see that something warm was there, in a place where nothing warm should be. In 1943, that was revolutionary, because for the first time in history, soldiers could detect living targets through smoke, fog, and rubble, using nothing but physics and heat. But this technology came with enormous drawbacks. 1. Overheating. The core chamber ran so hot that it needed several minutes of cool-down between uses. If pushed too hard, it would crack the glass or burn out the filament entirely. 2. Fragile components. Vacuum tubes are notoriously delicate. One rough movement, one dropped tripod, one mortar blast nearby, and the device would shatter instantly. 3. Power consumption. The lamp drank power like a monster. To run it in the field, soldiers needed portable generators, spare filaments, fuel, and heavy cables. You couldn't just pick it up and move. 4. Limited range. Depending on weather, the device could show silhouettes at 1040 meters in ideal cold conditions, but only 515 meters in fog or smoke. 5. Operator exposure. The device emitted visible light. Not a lot, but enough that an enemy sniper could spot the glare and fire at the operator's position. To put it simply, the heat gun worked, but not well enough to trust it on a battlefield. And this is why so few soldiers ever saw it. Most units never even heard of it. Only scattered engineering teams and test squads used the prototype, before it vanished into classified storage. But how close did it get to mass production? And why did it almost change the future of night combat? The answer begins with the field tests. When the first prototype of the heat gun was finally carried into a real battlefield environment, the reaction from soldiers was complicated. The first tests took place during winter operations, in bombed-out urban zones where visibility was practically zero. Snow fell in thick sheets. Smoke drifted endlessly from shattered buildings. Even during the day, the ruins were dim and silent. Into this environment, a small engineering unit dragged the massive tripod and the glowing heat chamber. One operator described the machine as a furnace on legs. Another joked that it looked like something pulled out of a science fiction novel. But when they powered it on, every joke stopped. The first major field test occurred near a collapsed apartment block where scouts reported possible enemy movement. The problem? No one could confirm it. Smoke from nearby fires drifted across every approach, making standard observation impossible. So the engineers set up the prototype. They activated the chamber. The lamp flared. A wave of shimmering hot light cut into the smoke. And then, just like in the lab tests, figures appeared. Faint, ghost-like silhouettes. 2, maybe 3 soldiers, hiding behind a wall nobody could see through. For the first time, Allied troops had visual confirmation of a hidden enemy without ever breaking cover. This was the moment that made commanders think the device might actually work. But reality set in quickly. The heat gun worked when conditions were perfect. Unfortunately, battlefield conditions are never perfect. Soldiers immediately noticed problems. 1. Snow interference. Falling snowflakes refracted the heat beam, creating dancing patterns of light and making silhouettes blur. 2. Brick variability. Not all bricks were the same temperature. Newly bombed walls were warm. Old walls were cold. The device couldn't differentiate perfectly. 3. Slow aiming. Because the device weighed so much, turning it even a few degrees took effort. Soldiers couldn't sweep an area quickly. 4. Battery and generator noise. Portable generators emitted noise that could alert enemy patrols. 5. Safety concerns. The chamber was dangerously hot. One operator later recalled that touching it accidentally would burn through a glove in seconds. Reaction among soldiers was mixed. Infantrymen loved the idea, a way to detect ambushes before walking into them. Snipers saw potential for spotting hidden targets. Recon teams imagined using it to check buildings before entering. But the operators themselves? They were more skeptical. Some thought it was far too fragile. Others said it required too much power and preparation to be useful in fast-moving combat. One engineer wrote in a report, promising results in limited conditions, impractical for frontline operations without significant redesign. Still, the tests proved one thing beyond doubt. The technology worked, just not well enough. And that left Allied Command with an agonizing question. Should they invest resources into refining the device, or abandon it in favor of emerging true infrared systems? The answer would determine the machine's fate and the future of night warfare. By early 1944, Allied engineers had enough field data to make a decision. The heat gun worked, but the reality of using it in battle was becoming impossible to ignore. Commanders met to review the test results. Reports praised the concept but warned about reliability, danger, and cost. One officer summarized the situation bluntly: effective in demonstrations, ineffective in combat. And so, the question shifted from "does it work?" to "is it worth continuing?" The biggest obstacle wasn't enemy fire, or the cold, or the fragile glass. It was logistics. 1. Weight and bulk. The heat gun required the main lamp assembly, vacuum tube cluster, a massive tripod, thick power cables, and a portable generator. Together, this weighed as much as a medium machine gun team's entire loadout. Moving it even 20 meters under fire was a challenge. Setting it up took several minutes, too slow for real combat. 2. Constant maintenance vacuum tubes burned out. Filaments cracked. Glass warped under heat stress. Frontline soldiers couldn't repair it. Only trained technicians could. 3. Extreme power consumption generators needed fuel. Fuel meant supply lines. Supply lines meant vulnerability. And some commanders refused to allocate precious gasoline to an experimental device. Or environmental sensitivity. Hot climates ruined thermal contrast. Fog distorted the optical chamber. Rain caused the beam to scatter. In short, the heat gun was powerful under very specific conditions and useless under most others. By the time tests were completed, another technology was already on the horizon: true infrared imaging. Germany had begun experimenting with active IR night scopes for tanks and snipers. The Allies had their own early infrared labs, and every month these systems became lighter, clearer, and more practical. Suddenly, the heat gun felt outdated, even though it was one of the first technologies to visualize warmth. Infrared could detect targets at longer range, function in more environments, be mounted on rifles or tanks, use less power, and avoid exposing the operator to visible light. The heat gun, by comparison, was bulky, fragile, and visible from a distance. In the brutal calculation of wartime development, ideas don't survive because they are brilliant. They survive because they are practical. The heat gun was brilliant. It was not practical. Despite its flaws, the device wasn't thrown away. Its existence was quietly classified, tested a few more times, and then stored in crates alongside other experimental oddities of the war. Reports were archived. Prototypes were shelved. Some were destroyed, a few survived, forgotten in storage. Decades later, historians uncovered scattered mentions in engineering logs and forgotten memos. Enough to reconstruct its purpose, enough to prove it was real, but not enough to tell its full story. And so, the most bizarre piece of thermal technology of World War II quietly faded into obscurity. But after the war, something unexpected happened. A rediscovery that almost brought the heat gun back to life. After World War II ended, the heat gun slipped into the quiet halls of military storage. Technicians packed it away in wooden crates marked experimental, do not deploy. The war moved on. Technology raced forward, and the device that once promised the ability to see through walls was all but forgotten. For years, it collected dust. Then, in the late 1940s and early 1950s, during a wave of post-war scientific interest, researchers reviewing captured and allied experimental equipment stumbled across something strange. A tripod-mounted device with a glowing thermal chamber, a mix of vacuum tubes, and optical focusing rigs. When engineers examined the parts, they realized what they were looking at: a prototype thermal imager, built before the concept had a name. The rediscovery fascinated Cold War scientists, not because it was practical, it never had been, but because it had attempted something no one else had tried: using light itself to reveal hidden heat. This was a conceptual breakthrough. Even if the execution was flawed, the idea was decades ahead of its time. By the 1950s, countries around the world were racing to develop early infrared systems. These new devices used electronic sensors, scanning mirrors, and emerging semiconductor materials. Compared to these, the WWII heat gun looked primitive, but its underlying principle, thermal contrast detection, aligned perfectly with Cold War research. Scientists studying the old prototype took note of several ideas: the concept of projecting controlled radiant energy, the use of thermal differential chambers focusing optics tuned for near-infrared wavelengths, the ability to visualize heat in real time. These principles reappeared, refined and modernized, in early thermal scopes and imaging systems. In a strange way, the forgotten heat gun wasn't a dead end. It was a missing evolutionary link, a transitional technology between visible light optics and true electronic thermal imaging. Today, the idea behind the heat gun survives everywhere. Police helicopters use thermal cameras to track suspects. Firefighters use handheld imagers to find people through smoke rescue teams detect survivors under rubble drones, use infrared sensors to spot heat signatures miles away. These systems are digital, precise, lightweight. Everything the WWII heat gun was not. But if you look closely at a modern FLIR image, the glowing human silhouette, bright against a dark background, it feels eerily familiar. It's the same idea, the same vision, the same dream. To reveal life where the eye can't see it. And although the heat gun never made it into mass production, its conceptual legacy lives on in every thermal device used today. But could this primitive WWII technology have gone even further? What would the world look like if armies in the 1940s had mastered thermal vision decades early? The answer lies in the realm of what if, a look into an alternate history. To understand the full impact of the heat gun, we have to step briefly into an alternate history, a world where the device worked flawlessly, and where Allied forces approved it for mass deployment. Imagine squads equipped not just with rifles and grenades, but with portable battlefield vision, years before night scopes, years before infrared. Imagine urban assaults where soldiers no longer entered buildings blind, because they could scan the interior first, revealing every human shape inside. Imagine patrols sweeping through fog-covered streets, knowing exactly where ambushers were hiding. Even a primitive thermal detection tool would have changed everything, because vision is survival. One of the deadliest aspects of WWII urban combat was the unknown. Every corner held a threat. Every wall could hide a sniper. Every room needed to be cleared with sheer courage and luck. But with a functional heat gun, the dynamic changes instantly. Scenario 1. Clearing buildings. Engineers estimated the device could detect warm bodies through thin brick or wood. This alone would have drastically reduced casualties during room-to-room fighting. Scenario 2. Detecting ambushes. Ambushes thrive on concealment. Remove that advantage, and the attacker loses the element of surprise. Scenario 3. Identifying occupied versus empty structures. Entire blocks could be scanned before advancing, giving commanders unprecedented clarity in chaotic environments. Even a limited-range silhouette detector would give an army a massive tactical advantage. Now, scale this technology up. If Allied forces had reliable thermal detection in 1944, night raids become far safer and more effective. Recon missions gain enormous stealth advantages. Enemy infiltration becomes far harder. Urban strongpoints lose their defensive dominance. Counter-sniper operations become dramatically easier. In short, many nighttime engagements would shift from deadly uncertainty to controlled, deliberate operations. And this doesn't even consider how enemies would respond. If the heat gun had become widely known, Axis forces would have developed countermeasures almost immediately. Possible responses include 1. Thickening exterior walls. Plaster, insulation, and sandbags reduce heat bleed-through. Cities might have been reinforced differently. 2. False thermal targets. Heated metal plates or dummy silhouettes could draw Allied fire or confuse scans. 3. Specialized camouflage. Germany was already experimenting with early IR camouflage nets. They might have developed crude anti-thermal cloaks decades early. 4. New battle tactics. Ambush teams would keep their distance from thin walls or rely more on underground movement. But even with countermeasures, the existence of thermal detection would force a major tactical evolution. Had this device reached full maturity, the late war battlefield might have looked very different. More controlled, more cautious, less dependent on luck, and more on science. But history took another path. the heat gun never reached mass production. Instead, it became a strange technological what if, a glimpse into a future that almost arrived 20 years too early. For decades after the war, the heat gun hovered in rumor. A strange story passed between historians and engineers. Some believed it never existed. Others thought it was a prototype that never left the lab. But the truth is stranger. The device did exist, and it nearly vanished not because it failed, but because it succeeded just enough to be classified. It touched on a capability militaries didn't want public, the ability to detect human beings through materials. Today, that sounds normal. In 1943, it bordered on science fiction. After the war, Allied intelligence reviewed every experimental technology. Projects that showed promise, even wild, unstable promise, were quietly labeled, restricted, further study required. This included early IR scopes, radar jammers, acoustic detectors, and the heat gun. There were several reasons for secrecy. 1. Fear of enemy replication. Even a flawed thermal device could inspire enemy research during the Cold War. 2. Ethical concerns. Seeing individuals through walls, even rudimentarily, raised early questions about misuse. 3. Protection of concepts. The principles behind the heat chamber and thermal contrast detection were too valuable to reveal. 4. The technology gap. By the 1950s, real infrared imaging was emerging. Admitting the earlier optical method had existed could compromise intelligence narratives. And so, the heat gun entered a strange limbo. Prototypes were boxed up. Some were destroyed during routine downsizing. Others were misplaced or stripped for parts. Only a handful survived, buried in archives, mislabeled, or forgotten on back shelves of depots. A few technicians remembered it, a few documents referenced it. But for nearly half a century, the device that let WWII soldiers see through walls simply disappeared. And that is why the heat gun became a ghost technology. Not quite a myth, not quite real, suspended in the space between innovation and obscurity. It was too early for its time, too fragile, too ambitious. Yet its core idea, the dream of revealing life hidden in darkness, lives on in every thermal imager used today. From a glowing chamber in a snowy battlefield, to modern thermal cameras scanning entire cities from the sky, the journey of this forgotten WWII device is nothing short of extraordinary. It was born in urgency, in a war where visibility meant survival. It promised a glimpse of a future no one was ready for. And although it vanished into storage crates and dusty archives, its legacy quietly shaped the world of imaging that came after. Today, every firefighter, every rescue drone, every border patrol unit, every aircraft using heat detection follows the same principle first tested by this crude, experimental heat gun, a machine that let soldiers, for the first time in history, see the unseen. If you've watched this far, you're exactly the kind of person who loves uncovering forgotten weapons, strange experiments, and hidden wartime technologies. This channel is filled with stories just like this one. Stories that almost disappeared forever. So if you want more, subscribe, leave a like, and share this video with someone who loves hidden history. Because the past is full of inventions that were decades ahead of their time, and we're just getting started.